for today, we're going to continue on our discussion of fundamentals. So we're already done with fundamentals of graph and degree of a vertex. This time, we are going to discuss fundamentals of path, cycles, and connectivity. Okay, so without further ado, let's start. First, we define what is a path and what is a cycle. So before we can define a path, we need to understand first what is a walk. So given a graph, a walk is a finite sequence of vertices and edges of this form. V sub 0, E sub 1, V sub 1, E sub 2, V sub 2, and so on and so forth. V sub k minus 1, E sub k, V sub k. So basically, you're following a series of vertex and edge. So vertex, edge, vertex, edge, vertex, edge. In such a way that two consecutive edges are adjacent or identical. So meaning a walk is like traveling on the graph. So you're moving from one vertex to another through an edge. So that means two edges must be adjacent. So hindi pwedeng tatalon. So you should follow adjacent edges. Yan. So vertex edge. So yung magkakatabing edge. So para kang naglalakad literally dun sa graph. So you're following the connected the adjacent edges. Yan. So we call the V sub 0 as the initial vertex and V sub k as the final vertex of a walk. So sometimes we call it a walk from V sub 0 to V sub k, indicating V sub 0 and V sub k as the initial and the final vertices, or simply a V0 VK walk. So that's how we abbreviate a walk. So we write the initial and the terminal or the final vertices. So the number of edges in a walk is called its length. So pagka naka 7 edges ka, then that's a walk with of length 7. So let's have an example. So let's say we have this graph where the vertices are U, X, V, and Y. And the edges there are two edges incident to U and X, so that's A and B. Two edges incident to X and V, so that's C and D. One edge incident to U and Y, one edge to incident to X and Y, to V and Y. And then there's a loop on vertex Y, loop H. Okay. So a walk is simply following from an initial point, vertex to vertex, through an edge to a final point. So let's say we have a walk. So we start with U. So we're starting here. This is our start. And then we follow the edges. So we walk on edge B from U to X. And then from X, edge E. And then from E, edge H, you're taking the loop H. And then you're back to Y since it's a loop. So you should go back to the same vertex. Tapos F here. Yan. So let me put an arrow so that we can follow the loop. Yan. Tapos to U and then edge A. And then X, C. Until you reach your final point. So that's a walk. So it's like you're traveling the graph along these edges. So let me repeat that. So from U, you go to X and then to Y and then go back to Y using the loop and then go back to U and then to X and then to V. So that's an example of a walk which is denoted as UV walk. Of course, a UV walk need not be unique. You can also follow different walks from U to B. For example, you can go straight from UX to V. Or you can go first to F and then go to the loop and then go to Y. So there are a lot of walk from U to V. So it doesn't necessarily mean na unique yung walk papunta sa from one initial point to the final point. So there could be a lot of walk. You can think of a walk as you performing a certain walk. So you're going through the edges. So pwede ka magpaikot-ikot, magpabalik-balik. So that's still a walk. So a walk in which all edges are distinct is a trail. So the difference between a walk and a trail is that a trail has distinct edges. So you can repeat a vertex, but for it to be a trail, you should have a distinct edges. Pag sinabing trail, you're talking of specific na dadaanan. So, ibig sabihin, pag naulit mo yung edge, hindi na yung trail. Kasi ang trail, dapat unique yung mga edge. So, a trail is a walk with distinct edges. Hindi na ulit yung edges. Yan. Pagka naman yung mga vertices ang unique or distinct, then that trail is called a path. Let's have an example para malinaw. So, for example, yung trail na UXYY UXV, that's a trail, but it's not a path. So, let's follow that particular trail. So, U, galing sa U, dadaan ka pupunta ka sa X using A, and then to Y using E, and then H, and then F. And then X, now this time using B, and then V using the edge C. So in this particular walk, we did not repeat any edge. So this is a trail. So a walk with distinct edges is a trail. But this is not a path. Why? Kasi umulit yung vertex U, umulit yung vertex Y, umulit yung vertex X. So, ang path, dapat pati vertices unique. For example, from U to V, a path could be U to X using A and then X to V using C. So, that's a path. Another path is U papuntang F. So, we cannot use the loop. So, parang, ang nangyari sa loop, if you can imagine a path, parang nagja-jogging ka lang in place, paikot-ikot ka lang in place. Kung ikaw, naglalakad ka lang in your place, so hindi path yun, kasi hindi naman nadadagdagan yung pinupuntahan mo. Okay, so from Y, you can go to X, and then go down to V. So, U to Y using F, Y to X using E, and then X to V using C. Okay, so that's a path. UXYV, UXYV is another path. It's also a trail, and it's also an example of a path. So, a path is a trail. A trail is a walk. Yung walk, para maging trail, kailangan walang repeated edge. Yung trail, para maging path, kailangan, bukod sa walang repeated edge, wala lang repeated vertices. Now, what is a cycle? A cycle is a closed path with at least one edge. So sa path, pwedeng may maulit na vertices, pero isa lang yung pwedeng maulit. Alin lang yon? Possibly yung initial vertex tsaka terminal vertex. So that's the only time that a path can repeat a vertex. Yung initial tsaka yung final vertices. But in that case, pag naulit yung initial tsaka final vertices in a path, then that's called a cycle. In general, pag yung walk or yung trail or yung path, initial vertex and final vertex are the same. That's called a closed walk or a closed trail or a closed path. Ibig sabihin, bumalik ka sa initial position mo. Pero, special case nun, pag yung path ay closed path, that's called a cycle. Okay? So, a closed walk or a closed trail need not be a cycle. Hindi ibig sabihin na pag close yung trail or yung walk, ay cycle na siya. Kasi pwedeng naulit yung vertex pagka walk siya. Or pag trail, pwedeng naulit yung vertices. So, a cycle hindi na uulit yung vertex or yung edges except on the initial and on the final vertex. Yun lang yung pwedeng maulit. Okay? So, in our example, U, X, V, Y, U. So, mula sa U, punta ka sa X, and then to Y, V muna pala. Punta ka sa U to X, X to V, V to Y, and then Y to U, back to U. So, that's a cycle. Yan. Okay? So, those are just different walks in a graph. So, lahat yan, walk, lahat yan. Ha? Pag nadagdagan ng restriction, naiiba lang ng pangalan yung walk. Pero all of them are walks. So, in our particular example, yung H, it's a loop, but it's also a cycle of length 1. So, again, ang initial vertex niya ay Y, ang terminal vertex niya Y din. Tapos, nag-loop ka lang. So, it's an example of a cycle of length 1. Yun namang U to X using A and then X to U using B, it's also a cycle, but this time of length 2. So, a cycle of length 1 is a loop. A cycle of length 2 is parallel edges. Ganyan yung parallel edges, di ba? Okay. So, pero pag simple yung graph mo, meaning wala kang parallel edges, tapos wala kang loops. So, ang pinakamaliit na cycle is of length 3 na. Kung simple yung graph, ha? Kung simple. Kung multi-graph, syempre pwede kang parallel edges, pwede kang magka-loop. Pero kung simple yung graph, the smallest cycle you can find is a triangle. That's a cycle of length 3. Okay. So, kanina, tinignan natin yung path as a subgraph ng isang graph. Pero syempre, pwede ka rin gumawa ng graph, which is a path. So, a path is a non-empty graph with vertex set V and edge set E, where V are V1 to Vk. So, those are the unique vertices in your path. And your edges are the edges connecting V0 to V1, V1 to V2, V2 to V3, and so on up to Vk minus 1 to Vk. So, the V sub i's here are all distinct. So, you should have K plus 1 vertices. The edges are also distinct. And according to how we write them, the edges are adjacent. The consecutive edges are adjacent. So the vertices V0 and Vk are linked by the path P and are called the ends of the path. So on a path, pwedeng sa V0 ka mag-start papuntang Vk or pwedeng yung Vk yung simula mo pabalik ng V sub 0. So pwedeng papunta ka sa Vk or ang path mo, pwedeng syempre, pwede namang pabalik din, di ba? Okay. So again, this is of length K since there are K edges and the number of vertices are K plus 1. Yan. In our path, we can just write them using the initial and the final point V0, Vk. Or pwede ring Vk, V0 path. Yan. Again, it doesn't matter naman kung saan ka mag-start. May dalawa kang endpoints ng path. So this is a path that connects the vertices V0, Vk. Pag simple yung graph, ang shortest path mo would be a path of length 0. Nag-start ka sa V0, nag-end ka sa V0. Ibig sabihin, wala kang edge na nadaanan. Okay. So, ang length nun, 0. 1 vertex and 0 edge. Yun yung smallest path. Yan. Ang susunod, syempre, yung 2 vertices with 1 edge. Susunod, 3 vertices with 2 edge. So, laging number of vertices minus 1 ang number of edges in a path. So as I've said a while ago, the number of edges in a path is called its length, and the path of length K is denoted by P sub K. So sometimes, we disregard the labeling. So kung walang label, ibig sabihin, meron ka lang mga vertices connected by edges. So that's a path of length 3. We will denote this as P sub 3. So yung mga special graph, tatandaan yung mga notations. So, medyo marami na akong binigay na special graph. Meron tayong Q sub K. Meron tayong complete graph. Yan. Yan. So, this time yung P is a path. Tapos yung C will be our cycle. Yan. We usually write a path according to the natural sequence of its vertices. So, kung paano yung pagkakasunod-sunod ng vertices, that's how we write a path. So, a path from x0 to xk is really x0, x1, x2, x3, and so on up to xk. So, if p equals x0, x1 up to xk minus 1 is a path, then the graph p plus idadagdag natin yung edge na x sub k minus 1 and x0. So, meaning, meron daw tayong path na x0, x1, x2, hanggang x sub k minus 1. So, meron tayong k vertices, k minus 1 edges. Tapos, idadagdag natin yung last edge na k minus 1 to 0. I-connect mo yung x sub k minus 1 doon sa initial na x sub 0. So, that becomes a cycle. Now, the cycle is of length k since meron tayong k edges. So, the number of vertices and the number of edges in a cycle are the same. So, again, kung simple yung graph, you cannot have a cycle of length 1 kasi walang loop sa simple graph. You cannot have a cycle of length 2 kasi walang parallel edges. Pero sa multi-graph, pwede yun. In simple graph, the smallest cycle is a triangle. So, we usually denote a cycle as C sub k. Yan. The minimum length of a cycle in a graph G is the girth of G. So, titingnan mo yung graph, hahanapin mo yung mga cycle niya na subgraph, yung pinakamaliit, yun yung girth niya. The maximum length on the other hand is called its circumference. Yan. So, pag G does not contain a cycle, we set the girth as 0 and its circumference to be infinite. Yan. So again, ang girth, yun yung smallest cycle contained in a graph. Tapos yung biggest cycle, it's its circumference. So this is an example. So let's say we have this graph. Okay? Kung titingnan natin yung graph na to, marami tayong cycle na makikita. So these are the possible cycles that we can find. C6 is actually this one. Yan. Tama? C4 is this one. That's a cycle of 4 vertices. Okay? Yung C5, ito siya. So, that's a cycle of 5 vertices. Yan. Now, ito, pwede nating tanggalin yung edge na to. And this is a cycle. Ito siya. With 8 vertices. Tama? So, ano pang pwede natin gawin? Pwede natin kunin to, tatanggalin natin to. So, that's a cycle. Yan. Size 7. Or, pwede rin na itong buo na to, tatanggalin lang natin itong dalawa na to. So, that's also a cycle. Right? And that's size 11. So, that's a C11 in our graph. So, in our graph, we were able to find C4, C5, C6, C7, C8, and C11. So, those are the cycles contained in our graph. And no other. Wala nang ibang cycle tayo makikita. Yun na lahat. So, the smallest cycles that we were able to find is this one. So, that means the girth of this graph is 4. And the largest cycle that we can find is this one. So, that's the circumference. So, that's 11. Yung iba, ang sinusulat sa circumference, ganyan. Kaya lang minsan nakakalito pag C. Kasi yung capital C, we already note or denote a cycle as C. So, parang nakakalito. Okay. So, anyway, we can just use the word circumference to mean circumference. Okay. Mahirap gamitin, nakakalito pag C yung ginamit. Sometimes, it's not wise to abuse your notation. Kasi mas nakakalito pag yung notation inuulit-ulit mo. This is a nice theorem about cycle. Every graph G contains a path of length delta G and cycle of length at least delta G plus 1. Okay, remember, ang delta G is the minimum degree of a vertex. Kung naalala pa. So, meron tayong last meeting, delta G, and This is small delta G and capital delta G. So that has something to do with the degree of a vertex. Meaning, ang delta G natin, small delta G, is the minimum number of edges incident to a vertex. Yan. Tapos, ang capital delta G is the maximum degree or the most number of edges incident to a vertex. So, for example, in our graph, this is of degree 1 kasi isa lang yung edge na incident sa kanya. This is of degree 3 nga, kasi may tatlong incident sa kanya. Okay? This is 2, degree 2. Yan. Okay, wala naman tayong degree 4. So, the minimum degree or the small delta G is 1 and the capital delta is 3. Capital delta is 3. Okay. Sabi ng theorem, every graph G contains a path of length delta G and a cycle of length at least delta G, small delta G plus 1. So, in any graph daw, makakakita ka ng path na ang length ay small delta G. Yun yung pinakamaliit na path na pwede mong makita. And a cycle of length at least delta G plus 1. So, since our delta G is 1, ibig sabihin, dapat makakita ka ng path of length 1, tapos a cycle of at least length 1 plus 1. So, at least length 2. But since this is a simple, so dapat at least length 3 tayo. Pag sinabi mong at least, hindi not necessary naman na equal eh. Ibig lang sabihin, yung cycle mo, mas malaki pa doon sa minimum na yun. So, to illustrate, consider any graph of minimal vertices with delta G equals N. So, for example, here, ang N natin is equal to 1. The minimum number of edges incident to a vertex. Pinakamalit na 1. Yan. So, dapat, makakakita tayo ng path of length 1. So, in any vertex, basta meron kang incidence value of at least 1, lagi kang may path of at least 1. So, that's your example. Pag ang N equals 2, ibig sabihin, ang isang vertex, at least may dalawang edge na incident sa kanya. Yan. So, that means, kailangan makakita ka ng path na of length 2. So, this is a path of length 2. Mula dito sa point na to, tsaka doon. Yan. And that is always true. Basta ang minimum. Ibig sabihin, yung ibang edge mo kasi, posible na ang incident sa kanya tatlo, or rather vertex. Ang incident sa kanya pwedeng dalawa, pwedeng tatlo. Kasi ang minimum natin ay 2. Okay? So, ang cycle mo, dapat makakita ka ng cycle of at least 3, which is this one. Remember, bawat isang vertex, at least may dalawang incident edge sa kanya. So, imposibleng mangyari na hindi ka makabuo ng triangle. For example, wala ito. Yan. So, imposible na itong point na to ay hindi mo mako-connect to other vertices kasi dapat at least 2 yung naka-incident sa kanya. So, kung meron kang point na may isa nang naka-incident, dapat may isa pang edge na naka-incident sa kanya. Pero itong point na to, dapat dalawa rin yung naka-incident sa kanya. So, dapat either mako-connect mo na siya dun sa iba pang vertices, or kung hindi siya naka-connect sa iba pang vertices, may bago ka na namang vertices na dapat may dalawang edge na naka-connect sa kanya. So, kahit ilan pa yung idagdag mong edge, dapat may isa doon na babalik at babalik into one of the remaining edges. Kasi dapat minimum of 2 ang makonect eh. So, makakabuo ka lagi ng cycle. Yun yung sinasabi ng theorem. And that cycle is at least 3 ang length. Pagka minimum mo, 2. Now, pag ang minimum number of incidents mo ay 3, lagi kang makikita na at least meron kang square. So, for example, wala muna yung mga edges. Tanggalin natin yung mga edges. So, alam natin na ito, mako-connect dapat sa 4. Dito tayo mag-start. So, dapat sa 3. So, dapat may 3 siyang incidents. Ayan. So, meaning, at least meron kang 4 at least meron kang 4 vertices. Kasi this first vertex should be connected to 3 other. Kasi ang minimum mo daw ng incidence ay 3 eh. So from this, mula dito, doon sa doon sa natitira pang vertex, dapat nakakonect ka rin doon. Kasi itong point na to dapat at least nakakonect sa tatlong edges. So ito na yung isa. So dapat may dalawa pa. Sabihin natin na hindi dito nakakonect at hindi dito nakakonect. So at least meron siyang kinukonekta na iba pa. Tama? Dalawa pa. Now, these two, kailangan bumalik na siya doon sa ibang vertex kung wala ka ng additional vertex pa. For example lang, yan na yung mga vertex mo, wala nang iba pa. So, meaning, dapat siya, bumalik na siya, madugtong mo na siya sa iba kasi kailangan may dalawa pa siyang nakakonect eh. Di ba? Kailangan nakakonect pa siya sa dalawa eh. Eh kung wala ka ng natitirang vertex, automatic, mako-connect ka na doon sa mga naunang vertices. And from our scenario, ito na agad yung square natin or quadrilateral natin. 4 edges, 4 vertices. So that's already a C4. So, ang sinasabi ng theorem, yung degree ng graph or the delta G of the graph ensures us that there's a path of that length and there's a cycle of that length plus 1. Kaya siya plus 1 kasi babalik eh. Babalik siya dun sa original. Kaya nagiging ito yung path. Tapos ibabalik mo siya, kaya nagiging cycle. Okay, ito ang degree nito, minimum of 3. So meaning, kada isang vertex nakakonect sa at least 4 na vertices. So ang minimum mo, meron ka minimum of 5 vertices para mabuo mo yung condition na minimum of 4 degree. Now, kung yan na yung mga vertices, wala nang iba, then that means lahat ng vertices mo nakakonect sa mga vertices. So, mabubuo mo yung K5. Right? Kung yan na lang yung mga vertices, kung wala nang iba. Syempre kung may iba pang vertices, pwede kang kumonek para mabuo mo. Pero minimum kasi, bawat isang vertex may 4 na nakakonect. May 4. So, nasan yung cycle? So, this is a cycle of size 5. This is your C5. So, the minimum degree is 4 and you can always find a cycle of length 4 plus 1, which is 5. Hindi sinasabing yun yung pinakamaliit na cycle. Ang sinasabi, garantisado, meron kang cycle of length C delta G plus 1 or Cn plus 1. So, in this case, meron kang C5. Okay? Each graph contains a path of length n and a cycle of length n plus 1, where n is the minimum degree of the graph. Okay, so let's prove that in general. So, suppose meron tayong path of length k denoted as x0, x1, x2, and so on. So, let's say from x0, makakarating ka up to x sub k using our path P. So, P is an x0, xk path. Alright. Anong sigurado na tayo pag ganito yung scenario? If x sub k has a neighbor u not in this path, let's say this one, neighbor siya ni k, pero wala siya sa path, then yung P prime is a longer path. But that cannot happen because we want P to be the longest path in G. So, meron daw tayong graph, kinuha natin yung longest path, tinawag natin siyang P rather. So, mula sa x0 hanggang doon sa kabilang dulo ng xk, siya na daw yung longest path. Wala nang mas mahaba pa sa kanya. So, ibig sabihin, kung merong neighbor si xk na wala doon sa path, yung P plus yung xku, mas mahaba doon sa path P. Which is a contradiction kasi sabi natin si path P ay ang longest. So meaning, hindi pwedeng si xk ay may neighbor na wala sa path. Yun yung sinasabi. So pag yung path natin ay longest, lahat ng neighbor ni xk nandun na sa path. So for let's say na ito na yung mga neighbor ni xk. Yan yung mga neighbor. Again, wala na tayong makikitang neighbor na wala sa path. Kasi pag meron ka pang neighbor na wala doon sa path, idugtong mo siya, mas mahaba yon. E yun yung pinakamahaba, hindi yung una nating nakita. Tama? So, laging yung dulo, nung pinakamahabang path, lahat ng neighbor niya nandun sa path. Hindi pwedeng may neighbor siya na wala sa path. Okay. So, at least, establish na natin yon. So, if this is the longest path, then all the neighbors of xk must lie on this path. No other neighbor can exist outside this path. Okay. So, it follows that yung minimum degree ng G is less than the degree of xk. Yan. And is less than or equal to the length of the path. Bakit less than or equal sa length ng path? Because there may be cases na hindi lahat ng nasa path ay neighbor ni xk. Pero kung lahat ng nasa path ay neighbor ni xk, then we have equality. Kung lahat yon neighbor ni xk, di ba? Kung lahat ng nasa path ay neighbor ni xk, then the number of edges in the path is the same as the degree of xk. So, yung number of incidents ni xk, laging, ito theorem to theorem yan from last lesson. Siyempre, minimum na to. Ito na yung pinakamaliit eh. E di kahit anong vertex, ang degree nun, laging greater than or equal to the minimum. Yan. And at the same time, since yung xk natin ay nasa path, yung number of vertices na connected kay xk ay laging less than or equal to k. Pinakamarami na yung k. Again, kasi in-establish natin na walang neighbor si xk na wala sa path. Lahat ng neighbor ni xk nasa path. So, ang maximum number of neighbors na ni xk yung mga point sa path. Okay. So, let I be the minimal element such that xi, xk is an edge. Alin yung minimal element na sinasabi nating I? Yung pinaka yung neighbor ni xk na pinakamalapit sa x sub 0. In this particular scenario, ito yon. So, ito si x sub I. Yan. So, kukunin mo lang naman yung pag tiningnan mo sa path, siya yung pinakamalapit sa x sub 0 or pinakamalayo sa xk with respect to the path. Pinakamalayo na siya. Yan. Bakit yun ang kinuha natin, yung pinakamalayo? Because this part of the path, ito, plus this edge, since yung xi is a neighbor of xk, so meaning my edge will form a cycle. Makakabuo tayo ng cycle. Tama? So, yung xi plus 1 up to xk, that's a cycle of length at least delta g plus 1. At least delta g. Bakit at least delta g? Kasi ito na lahat, ito yung delta, ito yung mga neighbors ni xk. Check na check tayo na yung mga number of neighbors ni xk ay mas maliit sa delta g. So, pag tiningnan mo yung cycle mo, 1, 2, 3, 4, 5, yan yung mga number of neighbors, plus yung edge na dinagdag mo, plus 1. For example lang, kung lahat na to neighbor. So, 1, 2, 3, 4. 1, 2, 3, 4, 5. Kung lahat yan neighbor. So, 5. Yung path, yung length, 1, 2, 3, 4, 5. Plus yung 1. Kaya, delta G plus 1. Okay? So, kung nagkataon na yung x0, neighbor din ni xk, edi yung cycle mo, xk plus 1. Kasi k yung length nung path, tapos plus yung edge na idadagdag mo, that's k plus 1. Or, yung pinaka minimum, delta g plus 1. Delta g meaning yung minimum number of incidents. Yan, next k. Okay? So, that's the reason why you always have a path of length k delta G, and a cycle of length K plus 1, delta G plus 1 rather. Delta G plus 1. Again, delta G is the minimum number of edges incident in a vertex. Okay? So now, let's define what we mean by connectivity. For a non-empty graph G, two vertices U and V are said to be connected if there is a path, if there is a UV path in G. So, iba yung ibig sabihin ng connected sa adjacent. Yan. For example, meron tayong UXV. Si UV, si U connected kay V because there's a path UXV. Tama? Pero si U tsaka si V, hindi sila adjacent. Bakit? Kasi wala namang edge from U to B. So, adjacency meaning dapat yung dalawang point adjacent. May edge, may isang edge connecting them. Pero kung path yung nagko-connect sa kanila, not necessarily adjacent sila, but they are connected. Siyempre kung isa lang, UV, adjacent sila, connected din sila. Yan. So, connected means there's a path connecting U to V. So, it can be just one edge or it could be multiple adjacent edges. So, dapat successively adjacent yung mga edges, ha? Mula kay U papunta kay B. So, dapat dugtong-dugtong. Yan. Para hanggang makarating ka kay V. Okay. In this case, we say that U is connected to V and G is connected if every pair of vertices in G is connected. So, ibig sabihin, kahit anong dalawang vertex ang kunin mo, laging may path from U to V. Laging may path from U to V. Then we say that graph is connected. Ganun lang naman kasimple. Or ibig sabihin, you can walk all the vertices pagka connected yung G. You can make a walk. Not necessarily a path. Kasi pwede mo naman paliitin yung pwede mo naman paliitin yung walk mo para maging path. Pero ang sinasabi ko lang, pag kaya mong lakarin papunta sa lahat ng point mo, lahat ng vertices mo, pag kaya mong lakarin, then your graph is connected. Yan. So parang yung mga island, parang may mga island ka, those are your vertices. Pag kaya mong puntahan lahat ng island by a certain walk, then your graph is connected. Ibig sabihin, merong bridge connecting each point. Hindi naman kailangan diretso yung bridge from one point to another. Basta kailangan lang makakapunta ka doon. So for example, wala itong edge na to. Ito lang. Yan. Connected pa rin siya. Kasi any point here, pwede mong lakarin mula sa isang point papunta to another. For example, start ka dito. Pwede mong lakarin papunta dito. Dadaan ka dito sa tatlo na to. Pwede kang makarating doon. Mula rito, pwede kang makarating sa lahat. So, napupuntahan mo lahat ng point. From one point to another, kaya mong lakarin. Okay? So, there is a path in G connecting any two vertices of G. Yan. So, that's what we mean by connected. So, as I was saying a while ago, adjacent vertices are connected, but connected vertices need not be adjacent. Because when you say adjacent vertices, it means there's an edge between two vertices. Pero when you say connected vertices, not necessarily an edge, but there is a path between these vertices. A vertex connected to itself by a path of length 0, but not self-adjacent for simple graph. So, pwede natin sabihin na ang U is connected to U. Bakit? Kasi that's a path from U to U. Di ba? Jog in place. O di nag-walk ka in place. O di, that's connected. U is connected to itself. Pero U is not adjacent to itself kung simple yung graph. Kung simple yung graph. Connected siya sa sarili niya, pero hindi siya adjacent kasi walang edge. Para maging adjacent ka kasi kailangan mo ng edge. So, kung may loop, nun lang magiging adjacent ang U sa sarili niya. Pero kung simple graph kasi, wala tayong loop, di ba? So, hindi adjacent ang point U sa sarili niya. Pero connected siya sa sarili niya. Yan. Okay. The relation connected between two vertices defined by U is related to V. So, kung naalala nyo pa yung set theory ninyo, U is related to B if and only if U and B are connected. So, that is a kind of relationship. Parang U is less than B. Yan, relationship. O kaya U is congruent to modulo B. So, those are examples of relations, di ba? Nung nag-set theory kayo. So, connectedness, the concept of connectedness of two vertices is an equivalence relation. Oh, paano yun? Let's just show that these are reflexive, symmetric, and transitive. So, we define the relation U is related to V if and only if U and V are connected. Reflexive siya, bakit? Kasi given U in our vertex set, di ba, U is always connected to itself. U is always connected to itself. Kasi there's always a path of length 0 from U to U. Di ba? There's always a path. This is of length 0. Ibig sabihin, parang ka lang nag-walk in place, nag-jog in place. Oh, connected pa rin yan. For as long as there's a path. By definition kasi, there should be a path connecting U to U. And there's always a trivial path of length 0. Okay, so reflexive siya. Meaning U is related to U. How about symmetry? So, anong kailangan sa symmetry? So, dapat meron kang dalawang point such that U is connected to B. Yan yung given. So, we want to show that V is also connected to U. So, ano ba ibig sabihin na ang U ay connected kay V? Ang ibig sabihin niyan, there is a UB path. Meron kang path from U to B. Tama? Ibig sabihin, may susundan ka, U, X, 1, X2, and so on, hanggang makarating ka sa X sub K minus 1, and then V yung terminal. So, U, V, may mapupuntahan kang path. Yan. So, there's a path given that U is connected to V. So, this time, pwede tayong bumalik. Ang ibig sabihin na ang UB ay path, syempre yung pabalik, path pa din yun. By definition ng path natin. Aling path yun? Yung pabalik. Yung V ka nag-start, and then xk minus 1, and so on, x2, x1, u. So, that's a path in G. So, that means V is connected to U. So, symmetric. If U is connected to V, then V is connected to U. Yan. How about transitivity? Paano natin pinapakita ang transitivity? So, transitivity, dapat given ka ng tatlong vertices, let's say U, V, W, such that CU connected kay V, tapos CV connected kay W. So, yan yung given. There are three vertices such that U is connected kay V and V is connected kay W. So, for example, ito si U. Connected daw siya kay W. So, dapat makakita tayo ng path papunta kay W. So, ang ibig sabihin ng connected si U kay V, there exists a UB path. UB path. So, ano ibig sabihin nun? Meron tayong U, X1, X2, and so on, up to X, K minus 1, tapos ang dulo niya, V. Tama? Okay. Now, si V tsaka si W, connected din daw. Ano ibig sabihin nun? So, meron tayong VW path. So, yung path na nag-start sa V, tapos, Y naman, not necessarily the same path di ba? So, Y naman, Y1, Y2, and so on, hanggang Y. Hindi kailangan sing haba. So, L minus 1, W. Iibayin niyo yung subscript pagka magkaibang graph yung pinag-uusapan, ha? Hindi hanggang K minus 1 lagi ng K minus 1. These are two different path, So, syempre, pwedeng magkaiba din sila ng length. Hindi naman ibig sabihin, magsing haba lang lahat ng, di ba? Pero pag puro K kasi ang ginamit yung subscript, ang ibig sabihin, magsing haba lang sila. Okay. So, ibig sabihin, mula dito sa, this should be V. Meron kang path na W, tama? So, for example, yan yung path mo. Pwede bang mag-cross sa'yo yung path? Pwede ba yun? Mag-cross sa'yo yung path ng V to W? Pwede ba? Pwede naman. Kasi ibang path naman eh. Wag lang magko-cross sa sarili niya. Pwede siya mag-cross sa ibang path, pero wag lang sa sarili niya. So, wag lang babalik ka dun sa mga point na to. Pero pwede mo namang gamit. Ayan, pwede yan. Iba natin kulay para medyo clear. Pwede na si V ay dadaan sa dinaanan na ni UV. Pwede yan, walang problema. Kasi ibang path naman yan eh. We're talking of two different paths. So it can happen that we have a path crossing from U to V. Okay. So, ang tanong, is there a path from U to W? Meron. All you need to do is to find yung common point kung may common man. Kung wala, ganito yung mangyayari kung wala eh. So, dalawang case kasi kung wala. Kung walang common point, magdudugtong lang silang dalawa. For example, walang common point. For example, hanggang dito lang si W. So, walang common point. So, mangyayari, yung U to V plus yung V to W is a path from U to W. Tama? Diretso lang. Path na siya. Eh, paano kung nagkaroon ng common point? O, gagawin mo lang, hahanapin mo lang yung pinakamalaking value ni Y or yung pinaka last point ng path ni W na nag-intersect sa path ni UV, which is this one. Ibig sabihin, meron kang makikitang subscript na Y sub S equal lang sa X sub T. Magkakaroon ng case na merong isang point dito tsaka isang point dito na magiging equal. Siyempre kasi magkakaroon ng common eh. Mag-intersect yung dalawang path eh. So, doon sa common point na yon, magsimula ka kay U. So, U, X1, X2, hanggang makita mo yung common point XT. Tama? Pero yung common point na yun, pareho lang doon sa YS, di ba? So, equal yung dalawa na yan. So, pagdating sa YS, papunta ka na ng W. So, YS plus 1, YS plus 2, and so on, hanggang makarating ka na kay W. So, ito yung path na yon. Hindi ka pwedeng umikot ha, kasi hindi path yung paikot eh. So, hindi mo pwedeng sabihin na pagdudugtungin mo lang yung UVW. That's not a path. Remember, a path cannot repeat a vertex. So, para masigurado mong hindi mag-repeat ng vertex, dun ka lang sa point kung saan nagtagpo yung dalawang point. Yung huling point na common, huling point ni UW na common kay UV path. Okay? So, this point. So, pag yun lang yung pagdudugtungin mo, ibig sabihin, aalisin mo lang yung circle, yung cycle. Kasi, pag may cycle ka, that's not a path. Okay? So, for example, ito yung U. Yan. Itong U to V. Tapos, itong V, nagpaikot-ikot. Yan. Nagpaikot-ikot. O, hanapin mo yung huling point kung saan sila nag-common. So, yun lang yung kukunin mo. Mula kay U, papunta kay V. Yun lang yung path. Kasi ito, hindi to path. Okay? That's not a path. But still, the point is, may path. Kailangan lang alam mo kung paano hanapin yung tamang path. Okay, so there's a path from U to V and there's a path from V to W. Always implies, it would imply that there's a UW path. Ano ibig sabihin? Ibig sabihin, U is related to W. So we're able to show three things. It's reflexive, it's symmetric, and it's transitive. Therefore, it's an equivalence relation. May drawing na pala ako kanina dito, dinrawing ko pa ulit. So, let me explain it again, baka mas madali pag ganitong drawing. So, ito yung UV path na distinct sa VW path. Magkarugtong lang sila pero walang common vertex. So, that whole thing is a UW path. Pero pag merong time na nag-intersect yung VW path, kukunin mo lang yung last point kung saan sila naging common. Last in the sense of the path of the VW path. So, ito yung kukunin mong UW path. So, that's a UW path. In either case, there's a UW path. So, U is related to W. So, this relation, if you remember the property of equivalence relation, laging pinapartition niya yung G. Di ba? Mag-i-induce siya lagi ng partition. An equivalence relation always induce a partition in G. So, ibig sabihin, i-induce nung connectedness relation ang partitions ng G, and each partition is called a component. So, how do we visualize a component? So, this is how we visualize a component. A component are the subgraph of G that are connected to each other. So, this is one component, this is another component, and this is another component. If that is a whole graph. So, that means, pinapartition niya yung graph natin into connected subgraphs. So, pag yung mga point hindi na connected sa subgraph, ibang component na yon. So, in this particular case, meron tayong 3 components. And no 2 components contain an edge. So, ibig sabihin kasi, kung may pang-connect dyan, magiging connected yung dalawa. So, magiging isang component lang yon. Okay? So, bawat isang component, walang edge connecting them. No component contains an edge. Again, kasi pag kinonect mo, because of this relation, magkakaroon ka na ng path from each point here to each point on the other component. So, magiging connected na yun. So, that will become one component. Yan. So, a component are disjoint subsets of graph. Disjoint in a sense that they contain no edge between them. Yan. So, a maximal connected subgraph of G is a subgraph that is connected and is not contained in any subgraph of G. So, for example, meron tayong graph, tapos there's an edges connecting them. Yan. So, this is maximal if wala nang mas malaki pang nagko-contain sa kanya na connected. Ibig sabihin, pag nagbawas ka ng isang edge dyan, nagiging disconnected na siya. Okay? So, a maximal connected subgraph is a subgraph that is connected and is not contained in any other subgraph of G. So, kung may iba pang point si G, dapat hindi na nakakonect sa kanya para masabi mo na siya ay maximal. Yan. A component of a graph G are its maximal connected subgraph. A component is trivial if it has no edges, otherwise it is non-trivial. So, ganun pa din. Pag isang point lang, yan. Pag null graph, so yung mga null graph, mga trivial component siya. So, pag nakakita ka ng tatlong point na walang edge connecting them, so those are 3 different components. Yan. All in all. So, hindi isa lang yun, di ba? Tatlo. Isang component lang. No. Tatlong components yan. Kasi walang edge connecting those 3. So, each isolated point is a component. Each isolated point is counted as a component. A components are pairwise disjoint, meaning they don't share a vertex. Not to share a vertex. And there is no edge between 2 components. This is very easy theorem to prove. Every graph with n vertices and k edges has at least n minus k components. Parang counting theorem siya. Pag meron kang graph with n vertices, ang number of components mo at least n minus k, where k is the number of edges. That's very easy to imagine. A graph with n vertices and no edges has n components. So, halimbawa, meron kang n vertices na walang edge. So, that has 6 components. Pero once na nagdagdag ka na ng isang edge, nababawasan yung component mo ng isa. Right? Kasi kinonect mo yung dalawa eh. So, nabawasan ka ng isang component because the 2 points kanina, which is counted as 2 different components, become 1 component. So, meron ka na lang 5 component. So, every time I add an edge, nababawasan ako ng at most isang component. So, for every edge na dinadagdag ko, at most, may isang nababawas na component. So, when k edges have been added already, the number of component is still at least n minus k. Tama? Pwede kasing magdagdag ako ng edge pero hindi nabawasan yung component. For example, nagdagdag ako ng loop. Or, tatlong edge na. So, pang-apat na edge. So, ilang component na? 3 na lang. 4 na edge na yung nadagdag ko. So, 6 minus 4. 2. So, at least 2 yung component. In this case, 3. Okay. This is also a counting theorem. Let G be a simple graph on n vertices. If G has k components, then the number m of edges of G satisfy the following. So, isa-isay natin. N yung number of vertices, k yung components. Then the number m of edges of G satisfy. So this is a lower bound and an upper bound for edges of G. N minus k yung lower bound. Tapos 1/2 n minus k, n minus k plus 1 yung upper bound. Okay. Let's look at our example a while ago. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 vertices. N is 10. 3 components, so k is 3. And then the number of edges is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. M equals 11. N minus k, M, 1/2, N minus k, N minus k plus 1. So this is 7. No. Right. 7. This is 11. This is 1/2 ng 7 times 8. So that's 7 times 4, 28. So indeed, 7 is less than or equal to 11 is less than or equal to 28. So always the number of edge is between n minus k and 1/2 n minus k n minus k plus 1. This is really easy to remember. Madaling tandaan yan, di ba? Pag na-common yung n minus k, 1/2 ng n minus k times n minus k plus 1. Let's see kung connected yung graph. Ibig sabihin, isa lang yung component niya. Let's see kung tama pa din yung inequality natin. So, let's have an example. So, let's connect this one. Iko-connect ko dito, iko-connect ko dito. So, we still have n as 10, pero this time, nadagdagan ng this becomes minus 1. Tama? So, n minus 1 is 9. The number of edges, nadagdagan ako ng dalawa, becomes 13. And then this becomes 9 times 10. So, that's 45. So, still, the inequality is correct. Let's try for K3. What's K3? Diba, K3 is, yan, that's K3. In K3, M is 3. Tama? The number of vertices is 3. And the upper bound is 1/2 3 times 4, 6. Tama pa din. So that's always the case. The lower bound and the upper bound of the edges is on the lower end, n minus k, on the upper end, 1/2 n minus k times n minus k plus 1. This is a very nice theorem because you can now count the minimum number of edges and the maximum number of edges for any given graph. Okay. This is quite tedious to show, kaya hindi ko napapakita sa inyo yung proof. Okay. So, but this is a good reading exercise. You can go to our reference book, tapos pwede nyo tingnan doon yung proof. Sobrang dali lang naman niyang intindihin. Okay. Now, a disconnecting set, or sometimes other author call it separating, is a set of edges whose deletion increase the number of components of the graph. So, ang disconnecting set, that's why it's called disconnecting. Very easy to remember. It makes your set or it makes your graph disconnected. So, those vertices that makes your graph disconnected, once you delete them, is called a disconnecting set. Pag vertex naman yung tinanggal mo, it's a separating. Uh, it it almost means the same, but we want to make distinctions para we're clear kung ano yung dinilit natin. Kung edges lang, or vertex yung dinilit natin. Remember, there's a difference pag dinilit mo yung edge tsaka yung vertex. Pag edge yung dinidelete mo, yung vertex natitira pa din. Pero pag vertex yung dinilit mo, kasama niyang nadidelete lahat ng edge na nakakonect sa vertex na yon. So, parang mas madami kang natatanggal pag vertex yung tinanggal mo. Unless yung vertex mo ay isolated, wala kang matatanggal na edge. Okay? So, once you delete a number of edges, or for a separating set, a number of vertex, tas naging disconnected yung graph mo, then those vertices or edges that you delete are called, for edges, a disconnecting set, for vertices, a separating set. But again, they mean the same thing. Ginawa mong disconnected yung graph by deleting them. Now, a cut set is a disconnecting set that is minimal. So, it's a minimal disconnecting set. Ano ibig sabihin ng minimal? Kung tatanggalan mo ng isang laman yon, hindi magiging disconnected yung set. Ibig sabihin, siya na yung pinaka-konti na magpapadisconnect sa set. Siyempre, kung dadamihan mo, mas masisigurado mo na disconnected, di ba? Pero, yung minimal is the least number of edges such that your graph will be disconnected. And pag binawasan mo yung disconnecting set na yon, hindi na disconnected yung set. So, yun yung ibig sabihin ng cut set. It's the minimal disconnecting set. So, it doesn't have a proper subset which will disconnect your set. Terminology lang, if a cut set has one edge, ang tawag doon ay cut edge, or in a simpler description, bridge. Yan. Kasi para siyang tulay that connect the two disconnected subgraph. And a cut set with only one vertex is called a cut vertex. So a cut edge contains only one edge. A cut vertex contains only one vertex. Pero may special na tawag yung cut edge, ang tawag sa kanya bridge. This is an example of a bridge, yung 5-7. Kasi when you delete 5-7, right away, madi-disconnect yung graph mo. So that means that's a bridge. Yan. So that's what we mean by a bridge. Para siyang tulay. Literally tulay na nagko-connect ng dalawang disconnected subgraph. Okay. So let's take this as our example. Let's say we have this graph with vertex set 1, 2, 3, and so on up to 9. And the edges are given in blue. So we have 1, 2, 1, 3, 2, 3, 1, 6, 3, 4, 6, 4, 6, 5, 4, 5, 5, 7, 7, 8, 7, 9. Okay. So, for example, if we remove edges 4, 6, 4, 5, and 5, 6, so 4, 6. No, that's not 4, 6. That's 4, 5. This is 4, 6, and this is 5, 6. So, after deleting the 3, naging disconnected yung graph natin. So, that's a disconnecting set. So, if we disconnect 5, 7, if we delete 5, 7, na-disconnect yung set, so that's also a disconnecting set. Now, kung ang dinelete ko lang ay yan. Tinira ko yung 4, 6. Inalis ko to sa set. Na-disconnect na yung graph. So that means, yung kaninang set, hindi minimal. because there's a smaller set that will disconnect the graph. If I delete 4, 5, and 5, 6, kahit maiwan yung 4, 6, disconnected pa rin. So this is not a cut set. So alin yung cut set dito? Ang cut set yung 4, 5, 5, 6. This is a cut edges. But this is not a bridge kasi dalawa yung kailangan kong i-delete para ma-disconnect siya. Ito yung bridge, yung 5, 7. So this is a bridge, yung 5, 7 is a bridge. Siyempre cut edge din siya. Isa lang na edge yung dinilit mo. Okay? Actually, in our example, yung 7, 8, bridge din. Right? Bridge din yung 7, 8. Bakit bridge din? So, kung i-connect ulit natin to, di-delete mo yung 7, 8, na-disconnect. So, bridge din siya. Right? Yung 7, 9, bridge din. Kasi na-disconnect siya. Yan. So, this graph has 3 bridges, 5, 7, 7, 8, and 7, 9. Yung mga bridge ng graph na to. 4, as I've said a while ago, yung 4, 6, 4, 5, 5, 6 is a disconnecting set but not a cut set. Kasi hindi siya minimal. Ang minimal yung 4, 5, tsaka 5, 6. 2, 1, 2, 3 are cut sets. Tingnan natin yung 2, 1, tsaka 2, 3. Pag tinanggal mo yung 2, 1, hindi siya disconnecting edge. Pero pag tinanggal mo yung 2, 3, disconnecting na din siya. So, cut set din siya. 1, 6, and 3, 4. 1, 6, 3, 4. Na-disconnect. So, that's a cut set. 2, 3, 1, 3. 2, 3, 1, 3. And 1, 6. So, those are cut sets. Because they are minimal. And they make your graph disconnected by deleting them. So, another cut set is this one. That's a cut set. Yung tinanggal natin, cut set yun. Because if I did not remove all of them, kung nagtira ako ng kahit isa lang sa kanila, for example, itong tatlo lang na to, connected pa rin siya. Itong tatlo lang na to, still connected. Itong tatlo lang na to, that's still connected. So, for it to be disconnected, kailangan tanggalin ko rin yung 2, 3. So, it's a cut set. Yan. So, there are a lot of cut sets. Not necessarily unique ang cut set. Yan. Pero, ganun pa din. Hindi ibig sabihin na yung cut set containing 2, 3 are always this cut set. Pwedeng the same edge is contained in a different cut set. Kasi di ba yung cut set na containing 2, 3 can be this set, yan, yung 1, 2, 2, 3 sa cut set, pero that same edge 2, 3 is also contained in this cut set. Yan. That's also contained in this cut set, yung 2, 3. So, a cut set is not unique. Yan. An edge is a bridge if and only if it belongs to no cycle. So, this is a very strong theorem. Lahat ng edge na walang cycle is a bridge. So in our example, as I mentioned a while ago, these three are bridges. 5, 7, 8, 9, tsaka 7, 7, 8, tsaka 7, 9. Those three are bridges because those three are the edges that does not belong to a cycle. Observe that any of the edges here are not bridges kasi lahat sila contained in a cycle. This edge is contained in this cycle. This edge may cycle. This edge may cycle. So, basta ang edge ay part ng cycle, it is not a bridge. So, those bridges are the edges that does not belong to a cycle. That's easy to prove. Let's imagine let's illustrate the proof. Let EUV be an edge on a graph. So, meron tayong edge. UB. Without loss of generality, assume that G is connected. Okay. Kung hindi connected ang G, gagamitin mo lang yung maximal na connected component, yung maximal component, kung nasan man yung G. Okay? So, let's just assume na connected yung G. Otherwise, just take the component of G containing E. So, okay. So, meron daw tayong connected graph. Again, kung disconnected yung graph, kunin mo lang yung component that would contain E. So, let's say meron tayong UV. Tapos merong E dyan. It's an edge on a graph. Now, it suffices to show that G minus E is connected if and only if E belongs to a cycle. Again, ang gusto nating sabihin, bridge lang yan kung walang cycle na nagko-contain dyan. Okay? Bridge yan kung walang cycle na nagko-contain dyan. Ang ibig sabihin nun, pag tinanggal natin yan, okay? Pag tinanggal natin yan, dapat ma-disconnect yung graph. So kung connected pa din yung graph, ibig sabihin, may cycle na nagko-contain sa kanya. Ibig sabihin, nako-connect pa rin siya in a different way. Hindi diretsong UV. Tama? Kasi kung may cycle na nagko-contain sa kanya, connected pa rin siya. Okay. So, pwede rin nating i-prove, G minus E is connected if and only if E belongs to a cycle. Meaning, kahit i-delete natin yung E, connected pa rin yung G kung yung E is connected to a cycle. Yan. So, dalawa yung ipoprove natin. If G minus E is connected, let's prove that E belongs to a cycle. And if E belongs to a cycle, we should be able to prove that G minus E is connected. Yan. So, suppose G minus E is connected. Okay. So, if G minus E is connected, then there's a path from U to V. Basta imagine niyo lang, may iba pang point sa graph. Pero dahil connected daw yung G minus E, so that means may magko-connect sa U tsaka sa B, not containing E kasi tinanggal nga natin yung E eh. So that means UV path belongs to G minus E. Pero observe that P, tapos idagdag natin yung edge E, nasa G na siya. Tama? Wala siya sa G minus E kasi yung E wala sa G eh. So pag dinagdag mo yung E sa P, yung P plus E ay nasa G, pero this P plus E is a cycle. In G. That's a cycle in G. Di ba? So pag ikinonect mo yung U at V, mapupunta ka sa G, you're a cycle in G. So that means UV is a cycle in G. So napakita natin na therefore, E belongs to a cycle in G. So basta yung G minus E connected, yung E nasa cycle. How do you form the cycle? Kukunin mo yung path na nasa G minus E, tapos idudugtong mo yung UV. That's already a cycle. Okay. On the other hand, paano kung ang isusuppose natin, E lies on a cycle in G? Para mapakita mo na ang isang graph ay connected from any 2 points. Meron kang U, meron kang V. Dapat laging may path papunta dyan. Kahit saan pa dumaan yung path. Basta laging dapat may path mula kay U papuntang kay V. Okay. So, ang i-assume natin, E lies in a cycle in G. So, let UV be an element of the vertex set of G. Okay. Ang alam natin, G is connected. Alam din natin na E lies in a cycle in G. Okay. Since G is connected, then G has a path P. Kasi G is connected eh. So kung si G lang yung titingnan natin, dapat makakakita tayo ng path papunta kay V. Yan. There's a path in G. Na kay G siya. Ang gusto natin ipakita, yung G minus E yung connected. Okay. Pero ang alam lang natin connected, yung G. Yan. Now, alam natin na ang E nasa cycle. So, kung titingnan natin si E is, ay wait, naulit yung UV ko. Si E pala fixed na UV. So, we cannot use an arbitrary element as UV. Dapat XY. Fixed na kasi si UV. Yan, dapat XY. Okay? Arbitrary element ng vertex, XY. So, if P does not contain E, unang scenario, pag si E wala kay P, ibig sabihin, yung G minus E, wala kang tatanggalin kay P. So, yung buong P, na kay G minus E. Yung buong P. Kasi, si E, wala naman kay P. Okay? So, yun yung case 1. Case 1, si E, wala dun sa path. Ibig sabihin, E is somewhere here. Ayan. UV. So, kahit tanggalin ko si E, yung G minus E, hindi maapektuhan yung path. So, yung path, na kay G minus E pa din. So, inside G minus E, connected pa rin si X at si Y. So, okay tayo doon. Now, what if yung UV nandito sa path? So, let's say nandito si U, nandito si V. May isang edge si path na E. So, what if ganun yung scenario? Okay? So, what if ganyan yung scenario? Yung E ay isang edge nung path. Pero dahil ang E ay cycle sa G, ibig sabihin, pwede kang gumawa ng cycle containing E. Tama? Now, yung cycle na yon, it can contain one or more points nung path. Pwedeng hanggang dito contain yung cycle. Ayan, pwedeng ganyan. Or pwedeng yung buo yung cycle. Walang problema. Basta at least, yung U at V ay part ng cycle. So, yung edge ay both nasa path at nasa cycle. Okay? Yung U, V, ay points sa path from X to Y. Yung edge E, both nasa path at nasa cycle. Okay. So, anong pwede natin gawin? So, tatanggalin na natin yung E. Kasi bubuin natin yung G minus E. So, pag tinanggal mo yung E, mawawala na to. So, what you can do now is you can create another path from X to U. So, this is a path from X to U. So, let's call that P1. From U to V, using the other side of the cycle, so let's call that P2. And then from B to Y, part of our original path, pero starting from V lang, up to Y. Let's call that P3. That's VY path. Neither of them contains E, so all of them are inside G minus E. Yung graph na tinanggal mo yung E. Tama? Yung path na yan. Pero observe that P1 plus P2 plus P3 is an XY path. Hindi pala an. AXY. Well, grammatically speaking, ano ba dapat? An XY o AXY? Mas tamang pakinggan yung an XY kasi X start with, the sound of X start with E. But anyway, this is not an English course naman. So, this is an XY path. That is in G minus E. So, anong ibig sabihin? Any XY is connected by a path. Yung UV man ay nasa path or wala. Pag yung UV wala sa path, edi that same path is in G minus E. Pag yung UV nasa path, tanggalin mo yung edge UV, makakabuo ka ng isa pang path, pero this time, dadaan ka dun sa other side of the cycle that contains E. So this G minus E is connected. So nakita natin na yung G minus E connected will imply E is in a cycle. Pag yung E is in a cycle, it would imply G minus E is connected. So that means, once yung E ay wala sa cycle at dinilit mo siya, madi-disconnect mo yung graph. Kasi para hindi siya ma-disconnect, kailangan nasa cycle siya. Pag wala siya sa cycle, madi-disconnect siya. Okay? So, yun yung napatunayan natin. But equivalently, that means that an edge will be a bridge if and only if it does not belong to a cycle. Because if that edge belong to a cycle, then removing it will maintain the connectivity of our graph. Para maging bridge ka, kailangan after removing that single edge, madi-disconnect na yung graph mo. Okay? So, there's a lot of properties going on in this proof. So, this is a good exercise for you to really imagine what's going on in a graph. So, pagka naintindihan mo yung proof na to, parang medyo naintindihan mo na yung concept ng connectedness and how a path and a cycle play in that connectedness. So, basta ang graph mo may mga cycle, laging hindi enough ang isang edge lang para ma-disconnect because of the cycle. Because a cycle, even removing an edge, will still remain another path. Ibig sabihin, basta ang isang path mo nagko-contain ng cycle, there are two possible way to go from point X to point Y. Pwedeng doon ka sa isang side ng cycle or doon ka sa kabilang side ng cycle. So that means a cycle will require at least two edge for it to be disconnected. Basta may cycle involved. Yan. Okay? Okay. So for a connected graph G, its edge connectivity denoted as lambda G is defined as the size of the smallest cut set in G. That is the smallest number of edges we need to delete in order to disconnect G. Okay. So, edge connectivity. Pag meron daw tayong graph, ang edge connectivity niya, parang i-describe niya kung gaano ka-connected ang graph through its edges. So, ang edge connectivity is denoted as lambda G. So, medyo dumadami yung variable natin. So, always remember the definition of the variable. So, meron tayong D, meron tayong delta, tsaka capital delta. So, D, English D, small delta D, capital delta D, always talks about the number of edges incident to a vertex. So, this tells us about D as in degree. So, remember, pagka degree, D delta, small delta or capital delta. Lambda, so parang tunog L siya. Lambda. Talks about edge connectivity. The size of the smallest cut set in G. Pinakamaliit na cut set. Ibig sabihin, that's the minimum number of edges you need to delete in order to make your set disconnected. Okay. So this is an example. What if you have a null set? A set which contains only vertices but no edges on them. So, right away, this is a disconnected graph. Kasi meron kang 1, 2, 3, 4, 5, 6 component. A connected graph has only one component. And a null set has n components, number of vertices components. So this is disconnected. So meaning, ang minimum number of edge that you need to delete is 0. So that means that the lambda of G is 0. Wala ka na wala i-delete para maging disconnected siya. So let's take a path as another example. A path is a connected graph joining two endpoints. So this is one endpoint and this is another endpoint. So how do you make it disconnected? Just delete any edge. So if you delete any edge, it becomes disconnected. So the minimum number of edge you need to delete is 1. That's the minimum. Madi-disconnect din siya kung dalawa tatanggalin mo. Madi-disconnect din siya kung tatlo tatanggalin mo and so on. Pero the minimum number that you need to disconnect is 1. Kaya lambda G is 1. For a cycle, as I've said a while ago, kailangan mo ng at least dalawa to disconnect it. Ito, tsaka any other edges. For example, this one. So you need at least 2 to disconnect a cycle. So lambda of a cycle is 2. This is a K6. So let's see how many number of edges is required to delete for this to be disconnected. So let's delete this one. Okay. Let me delete this one again. Nakadalawa na tayo. Tatlo, 4, 5. So at least it required 5. Pwedeng mas madami pa. Pero the minimum is 5. Let's see in other cases kung 5 na. For example, I want to disconnect this side from this side. Yan. Gusto ko matira lang na dalawang component yon. So meaning, kailangan ko i-delete lahat tong edges connecting those two. So 1, 2, 3, 4, 5, 6, 7, 8. So I need 8 edges to make those two components. Still, the minimum number is 5. Let's look at another instances. What if I want to disconnect this 3 from this 3? Yan. So gusto ko maiwan to as one component and this as another component. So meaning all the edges here must go 1, 2, 3, 4, 5, 6, 7, 8, 9. So still, the minimum number is 5. And that happens if you want to disconnect 1 to the rest. Yan. Nun mo lang magagawa yung minimum number. You want to disconnect 1 point to the rest. So you delete this 5 connecting those points. So that's a disconnected already. Okay. So if the number of edges is n, then the minimum number is n minus 1. So for this case, it's 5. So in general, it's n minus 1. So that's what we mean by edge connected. Now, we say that G is L edge connected if the order of B is greater than 1. Kailangan at least kasi magkaroon tayo ng edge. And G minus F is connected for every set F subset of the edge with the number of elements of F less than L. This means that G remains connected even after deleting L minus 1 edges. So parang dinidescribe mo yung set. Okay, this set is 2 edge connected. So that means if it's 2 edge connected, at least 2 edges connects every point. Meaning, if I remove 2 edges, pwede nang ma-disconnect. Pero kung less than that, connected pa rin siya. So in short, any number less than or equal to the lambda G is a value of L para sa L-edge connectivity ng graph natin. So parang dinidescribe mo lang yung type of connectivity na meron with respect to edge ng graph natin. And ang maximum number na ni L ay yung lambda. Ulitin natin. Yung L-edge connectivity natin is the number in which pag mas konti yung tatanggalin mong edge, connected pa rin yung graph. So for example, yung cycle natin, it's a 2 edge connected. Ibig sabihin, kung magtatanggal ako ng isang edge lang, connected pa rin yung graph. Pero kung magtatanggal na ako ng dalawang edge, posible na siyang maging disconnected. Yan. Pero one edge connected din siya. Ibig sabihin, kung hindi ako magtatanggal ng isang edge, connected pa rin yung graph. So, pag ang lambda mo ay 2, you are 0, you are 1, and you are 2 edge connected. Kasi any number less than L will still make your, or removing any edge less than L, will still make your graph connected. Yan. So, parang yung L, siya lang yung mga number from 0 up to lambda. Yun yung L. So, a 5 edge connectivity means siya ay 0 edge connected, 1 edge connected, 2 edge connected, and so on. So, yung pinakamalaking edge connectivity, that's your lambda. That's one way of finding the value of lambda. Ibig sabihin, hanggat nagdi-disconnect ka ng mga edges at nananatiling connected yung graph mo, then your G is L edge connected. Yung pinakamalaking L edge connectivity, that will be your lambda. Okay. Pero another way of finding lambda is determining the minimum number of edge that you need to delete to make it disconnected. So, in terms of cut set, it's the smallest cut set that you can find. Smallest cut set or biggest edge connectivity. That's your edge connectivity. Biggest L edge connectivity rather. Okay. Let's take a look at our previous example. This is one edge connected only because there's a bridge in the graph. Meaning, if I delete one edge, 5, 7, so isa lang yung tinanggal ko, naging disconnected na siya. So, one edge connected lang siya. Pero for example, hindi kasali yung tail. Parang isda siya na may buntot, di ba? Huwag natin isama yung tail. Kung yan lang. So, the minimum number of edges that is required to delete to make it disconnected is 2. For example, this 2. That makes your graph disconnected. So, this has edge connectivity 2. Lambda of G is 2. Kasi yun na yung minimal cut set. Cut set are not necessarily distinct, ha? Pwede rin ito rin yung dinilit mo. Okay. So, pwedeng ito rin cut set din to. Yan. That's also a cut set. Pero, 4 yung laman ng cut set. So, it has as cut set, a minimum cut set with 2 elements. So, that means, ang lambda G ay 2. Para dito, para sa graph na to. Pero kung yung original, yung may tail, ang minimum cut set natin is a bridge. Yeah. So, 1 ang delta G nito. So, lambda G is equal to 1. Row number 9 and 10 is the manager of a primary filter or the primary. Another theorem, a graph G is L-edge connected if and only if any two distinct vertices of G are joined by at least L paths, no two of which have any edge in common. Yan. So, the number of L-edge connectivity can also be determined by the number of distinct paths you can form from one point to another, to any two distinct vertices. So, kung ilang unique path or disjoint path yung pwede mong, so when we say disjoint path, no edge in common. You can form from one point to another. So, for example, here, for any distinct 2 points, so for example, let me get arbitrary point U and V. How many distinct path can we make? So, not two edge in common, pero pwede namang may common vertices. So, for example, this is one path, and this is another path. So, no other path can be made. Hindi ka naman pwedeng dumiretso. Wala namang edge dun eh. And in fact, nagamit na lahat ng edge. So, there's no other path that you can make. So, at most, 2 edge connected siya. Tama? Yes. Okay. So, here, this is UV for any point UV. So, kahit saan mo dalhin yung UV. This is one path. Yan, may path doon. This is another path. So, 1, 2, 3 edges. So, this is P3. This is another path. 1, 2, punta doon. That's also P3. This is not P sub 1, this is P sub 2. This is P sub 4. Yan. So I have P1, P3, and another P3. So 3 different paths. So at most, this is at most 3 edge connected. How about this one? U to V. I can put any, I can choose any 2 points V ha. Hindi naman kailangan ito. Pwedeng ito din. O, yan. If you want that. So, this is one path. This is another path. So, hindi na ako pwedeng dumaan sa taas. So, bababa ako dito. 1, 1. Tapos dun sa ilalim, dun sa gilid. That's another path. So, I cannot have any other path kasi lahat ng edges going out from you, nagamit ko na. So, I cannot have any more than 3 paths that I can take from U to V. So, that means this is at most 3 edge connected. So, if this is at most 3 edge connected, so yun ang pinaka mataas na L edge connectivity. So, delta lambda G is 3. Here, lambda G is 3 as well. And here, lambda G is 2. So, the nice thing about this theorem it tells us how to exhaust all the path from one point to another, and that will give us the number of edge connectedness of the graph. Again, that's the number of path you can take, distinct path, meaning path with distinct edges, no edge in common. Yeah. For a connected graph G, it's vertex connectivity. So this time, ang sinusukat naman natin is the connectivity of the vertices. Kanina, ang sinusukat natin is connectivity ng edges. So this time, how is it connected or how is the graph connected in the point of view of the vertex? So it's vertex connectivity or simply connectivity denoted by chi of G. So that's a Greek letter chi. Parang X, yung parang X na chi. C-H-I. Yan. Chi. Is the size of the smallest separating set in G. So pag sinabi mo smallest separating set, you're deleting now a vertex. But again, to remind everyone, when you delete a vertex, lahat ng incident edges dun sa vertex na yun, nadi-delete din. So in a way, mas marami kang dinidelete pagka separating set. That is the smallest number of vertices we need to delete in order to disconnect G. So, minimum number of cut set in terms of vertices. Okay. So, for example, mayroon tayong path. So, ilang vertex ang kailangan nating i-delete? Well, kung ang i-delete mo is the endpoint, it will still be connected. So, wag endpoint ang i-delete. So, let's delete any point other than the vertex. And we're sure na madi-disconnect. So, a path is always one vertex connected. So, ang connectivity natin is 1 for a path. For a cycle, pag nag-delete ako ng isang vertex, kasama yung edge, connected pa din. So, on the remaining cycle, nagiging path. Huwag mo i-delete yung endpoint. Kasi alam na natin, pag endpoint ang dinelete mo sa path, connected pa din yung natitira. So, let's delete any other point except the endpoint. And that makes your graph disconnected. So, ilang vertex yung kinailangan? 2. So, the vertex connectivity of the cycle is 2. Now, if your cycle only has 3, for the test data? Only has 3. So, pag dinelete mo yung dalawa, yung natitira, connected pa din. Kasi isang component na lang, di ba? So, technically, you need at least 4 for a cycle to make it disconnected. Pag vertex ang dinidelete. Yan. Okay. Fish. So, if you can find the very special point that will make it disconnected, then you will see it only requires one to make it disconnected. That's the cut vertex. If you remember the cut vertex, a separating set with only one element or one vertex. So parang yun yung parang bridge, para siyang bridge. Pagka dinilit mo yung isang point lang na yun, nadi-disconnect na siya. Pero ang difference, ang bridge, wala kang tulay. Iyan parang point lang. May point lang na nagdudugtong nung dalawang, parang yung point na to, dinudugtong niya yung dalawang subcomponent. Yan. If you delete any other point, hindi magiging disconnected agad yung graph. That will require you to delete another point to make it disconnected. Okay? So that means that's not the minimal cut set. The minimal cut set is this point here. Yung kung saan yung pinaka parang bridge niya. Walang special na tawag sa cut vertex. Cut vertex lang. Ayan. Kasi in real life parang siyang point that connects to separate component. Okay? So if you have a cut vertex, of course, that will make your vertex connectivity only one because of the cut vertex. That means the higher the value of the vertex connectivity, the more connected. You can imagine that the more connected a graph is. So parang in terms of connectivity, mas maraming connections, mas mataas yung vertex connectivity. Pero pag nagkakaroon ka ng isang vertex set or isang bridge, parang nandun yung weak point or weak link. Kasi pag dinestroy mo yung bridge na yun, nadi-disconnect. So, you can just imagine if you're talking of a network, parang vulnerable point siya. Imagine if an internet is always passing through one specific server. Parang meron kang internet, an internet is interconnectivity ng lahat ng mga router, di ba? So, for example, kung meron kang internet that needs to pass through a specific server from one point to another, hindi makaka-connect ang U sa V kung hindi dadaan sa point na yan. That's a weak link. That's a very vulnerable graph. That's a very vulnerable network. Bakit? Kasi target yan eh. Pag binomba yung server na yan, disconnected yung yung network mo. Right? So, if you can increase the number of connectivity, then you can improve your connection. So, yun yung ibig sabihin natin ng edge connectivity tsaka ng vertex connectivity. It's how your graph are connected. Yan. So, sa point of view ng networks, the lower the connectivity, the more vulnerable your network is. Okay, let's have a look at the next example. So every point here is connected to the three edges on the opposite end. So ano yung point connectivity natin? Let's try to delete vertex. Let's delete this one. Connected pa rin yung natira. Let's delete this one. Connected pa din yung natira. Let's delete this one. This one. So, it requires to delete 4 points para bago ma-disconnect. So, let's see, baka naman merong mas konting disconnecting vertices, disconnecting set. What if I delete again that one, and instead of the opposite dun sa baba, itong nasa kanan. Connected pa din. So, let me delete this one. So, 3. Tama. Do you think 2 is enough? Can I delete? Can you find 2 points na magiging disconnected yung graph? Pair of 2 points that will make the graph disconnected. Any 2 na 1 from above, 1 from below, connected pa rin yung natitira. So, hindi 1 from above, 1 from below. 1 from above, 1 from below. Laging connected pa rin. Sir, paano kung 2 from the same side? Connected pa din. Connected pa din. So, what does that mean? it requires at least 3 to make it a disconnected graph. So that means the minimum number is 3. So anything lower than that, connected pa rin. Okay? So that's what you mean by vertex connectivity. It's the size of the smallest separating set. Anything smaller than that will not make your graph disconnected. How about the last graph? Let me try to delete this one.
Did they mention what kind of help? I mean, are they gonna join the calls or
So since
have you
there
directed
are
them the
cycles
question? We don't know yet.
on
Okay.
each of the
Okay.
edges involved, deleting one point will not make it disconnected. Kasi alam na natin pag cycle, kailangan mo ng at least dalawa para ma-disconnect yung cycle. Tama? Pag may cycle ka, you always need at least two to make it disconnected. Because if I delete just one, it will not make it disconnected. So, to disconnect it inside a cycle, so tatlong cycle na maliliit yan.
Okay.
For example, this cycle, or this cycle. May isa pang malaking cycle. So, for me to disconnect it, I need to delete at least two vertices. So for example, if I delete this one, no, that's the wrong that's the wrong vertex to delete.
Okay.
If I delete this one and this one, so that makes it disconnected. So 3. So let's see if meron pang ibang pwede. Baka mali yung unang na-delete ko. Para baka kaya ng dalawa lang. If I delete this one, parang ganun din yung natira kanina, di ba? Parang ibang orientation lang. So, kailangan ko ulit ng dalawa para ma-disconnect siya. Dalawa pa din, no? Dalawa pa din para ma-disconnect. So, that means the minimum number is 3. So, that's your vertex connectivity. Nakuha po ba ibig sabihin ng vertex connectivity? Now, to describe vertex connectivity, ganun din, it is said to be K-connected if you have at least one vertex and G minus X is connected for every set X whose number of elements is less than K. So, parang kanina yung edge connected, ito vertex connected or simply connected. So, it's K connected if deleting fewer number of vertex will not make your edge disconnected. So, ibig sabihin, K-connected ka. Okay? So, again, K-connectivity is any number less than or equal to your chi value. Ayan. So, pag ang graph mo has vertex connectivity 3, then you are 0 connected, 1 connected, 2 connected, and of course, 3 connected as well. Ibig sabihin kasi, 2 connected din siya eh. Kasi pag nag-delete ka ng less than 2, connected pa rin. So, 2 connected siya. Pag nag-delete ka ng less than 1, ibig sabihin, wala ka i-delete, connected pa rin. So, 1 connected ka. Yan. Vertex connectivity pala starts with 1. Hindi pala kasama yung 0. Kasi hindi ka naman pwede mag-delete ng negative 1 vertex. So, you are either 1 connected, 2 connected, 3 connected, and so on, up to maximum value mo ay chi of G. Yan. So, those are examples of graph with different value of chi. Now, parang sa bridge, once meron kang cut vertex, ang chi mo at most 1. So, again, that's a very vulnerable in terms of graph. That's a vulnerable graph. Kasi, isa lang yung, tanggalin mo lang yung specific vulnerability na yun, disconnected na siya. So, parang siya yung counterpart ng bridge. So, no matter how connected your components, parang, for example, very connected yung isang side. Yan. And then, for example, meron ka pa ritong isang side. Yan. Pero, the only thing that connects those two components are a single bridge. then the connectivity still is very weak. Kasi that's just one edge connected. Because once you remove this bridge, they're already disconnected. Kahit na as a subcomponent, parang itong component na to is K6, so very connected siya, di ba? Hindi pa pala K6 yan. Kulang pa pala ako ng edge. Okay? So again, the edge connectivity and the vertex connectivity describe how connected your graph is. Now, the nice thing about connectivity is that it can be described as well by the path. A graph G with at least K plus 1 vertices is K connected if and only if any two vertices of G are joined by at least K path, no two of which have any other vertices. So this time, you cannot have a vertex in common. Kanina, at sa edge connectivity, pwede kang magkaroon ng common vertex basta wala kang common edge. Now, sa vertex connectivity, your path must be distinct and disjoint. So, walang common vertices except syempre yung first and last. So, anywhere in between, hindi pwedeng may common vertices. So, that will dictate how connected your graph is. So, the graph G with at least K plus 1 vertices is K connected if and only if any two vertices of G are joined by at least K paths. So, for example, here, there's only one path connecting U and V. So, one connected lang siya. But in this case, in a cycle, there are two paths connecting any 2 points. Any distinct 2 points in your graph can be connected by two distinct paths. Now, this is one connected because once your points are on either side, so for example, you have a point here and a point here, you only have one path with distinct vertices to go from U to V. So this is one path and this is another path, but since this is a common vertex, then it will only count as one. Kasi inire-require na dapat isa lang. So, dapat isa lang, dapat unique yung mga vertices ng path. So, your path cannot have a common vertex. Pero this one is a two-edge connected. Kasi may dalawa kang edge na nakita from U to V. So, as an edge, in terms of edge connectivity, this is two-edge connected. But this is only one vertex connected because of this. Because you have a cut vertex. Okay? Now, this one, we've already shown before na meron kang for any 2 points. So, for example, this is U, this is V. You can always have three distinct paths. A straight path or a path na dadaan muna dun sa iba. So, for example, let me go from here and then up here and then go back here. So, that's one path. Another path is this one, papunta dito. So, no common vertex except the first and the last. So, there are three distinct paths from U to V. For any point for that matter. Kahit saan kunin mo yung points. For example, ilipat natin yung UV. Kasi ito yung U, ito yung V. So, paano ka makakapunta doon? This is one path. 1. This is another path. 2. And this is another path. 3. So, no other path kasi na-exhaust mo na lahat nung coming from U na path. So, tatlo lang kasi yung incident kay U. That's always the case. The number of paths you can make from a point is at most the number of edges incident to that point. Siyempre, hindi na pwedeng lumagpas pa doon, di ba? Kasi siyempre, wala ka nang dadaan ng iba, kundi doon sa mga edge na naka-incident sa'yo. Same case, kung saan ka papunta, the maximum number would be the number of edges kung saan ka papunta. So, at most 3. And in this case, we found exactly 3. So, the edge connectivity, the vertex connectivity rather is 3. Here, ano yung mga path na pwede natin? For example, let me take this one and this one, UV. So, pwedeng dito sa left side, that's one path. So, I cannot take that path anymore. As a cycle, dun ako sa kabila. dun sa baba, that's another path. So there's another edge here coming out from U. So I can go to V, uh, but not going through the side, the left side. So dito na ako dadaan sa kabilang side. Ayan. So 3 din. So it's also 3 vertex connectivity eh. Kaya at most 3 path dapat ang makuha mo. Yun nga yung sinasabi ng theorem eh. So the number of path is the same as the vertex connectivity. So a graph with at least k plus 1 vertices is k connected if any 2 vertices of G are joined by at least k path, no two of which have any other vertices in common. Again, once na makakita ka na ng cut vertex or cut edge, yung point connectivity mo, always 1. Kasi pagdating doon, kahit gaano pa connected dito, kahit ilang path pa yun, pagdating doon, laging isa lang yung path. Laging yun lang yung path. So, that makes your path connectivity or edge connectivity or vertex connectivity equal to 1. So, that's a very nice theorem. Okay. So, at this point, let me cut the discussion short. Now, for the remaining 1 hour, I want you to meet with your group mates and formulate your proposal para mabuo na yung proposal ng exposition. So, for the rest of the time, please use the rest of the time to formulate your proposal. So, at this point, kung hindi pa kayo nakapag search ng mga readings regarding your topic, so go ahead and find some readings, discuss kahit naman konti pa lang yung reading among yourselves, you can discuss kung ano yung gusto nyong pag-usapan dun sa proposal ninyo. Make it a point that you find time today to formulate and compose your proposal so that I can review it this week. Para kung may mga comment pa ako until Friday, you can still edit your proposal. So, I'll set the deadline for proposal next meeting para medyo masimulan nyo na agad yung flow ng inyong magiging exposition. So, that will be your activities for this week, the weekly assessment and the proposal.